All right, thanks everyone and welcome. Just a quick correction, I'm not a data scientist, I'm actually the Iguazio VP product, but it's nice that you position me as a data scientist. And today's session, I'm going to talk about real-time feature engineering with a feature store. So I'm going to start with a few slides and then move on to a demo where I'm going to show you how we do feature engineering on top of Iguazio, especially around real-time feature engineering, all the way down to model serving and model monitoring. So as we all know, AI today is at the heart of every industry, and customers are implementing AI across various verticals. And I can tell you from our experience in Iguazio that we see lots of traction around online and real-time use cases, which makes the operational challenges much more bigger than the typical batch inference. So we can see that across different verticals like finance and e-commerce and healthcare and manufacturing. Lots of use cases are out there that are more oriented to real time. So let me give you a couple of examples from the manufacturing segment, predictive maintenance. So if you want to predict whether an engine will fail in the next few hours or so, it means that you basically need to get the average parameters like sensors, the average sensor or vibration or pressure of your device in the last few minutes or the last half an hour. If we're talking about real-time recommendation and you need to recommend next news article to read, that's going to be based on the last articles that the user have been reading in the last few seconds or sometimes minutes. And this type of information is going to serve your model. Order optimization. If you want to estimate how long the food delivery will take, you need to take under consideration things like incoming order, outstanding orders in the last few minutes, in the last hour or so. And in finance, fraud prediction, which we can see that across verticals, to be honest. If you want to predict fraud transaction, it means that you need to get the last amount and the last volume and the location. So for instance, if I'm issuing a transaction in the UK and 2 minutes after I'm doing the same thing in the US, it doesn't make sense, right? So all that information is information that you can get in real time, in live events. This is not something that you can do as part of a batch processing. You cannot do it overnight simply because you don't have this data. And this data is required to process your feature engineering and required for your model to operate successfully in real time. Now, why is it hard? First and foremost, performance. So you need to calculate those features in real time on live data. You need to do it at scale. So you may have thousands of features that you need to calculate. We have customers that are actually calculating thousands of features every second, and that's a lot. And you need to take care for scalability, to scale up, scale down based on the workload, and that's a pretty big effort. And you need to make sure that you can meet your SLA. So at the end of the day, in some cases, your SLA could be a couple of milliseconds, maybe one second or so. But those feature engineering needs to happen in real time. And as part of this feature engineering, you have robust transformation that you need to put in place, right? So you need to calculate things like sliding window aggregation and all kinds of transformation. You may need to calculate z-score on the fly. It means that you need to calculate different features so you can eventually calculate the z-score from your events. And you may need to enrich the data and join different data sets. So if we're taking the fraud example, you have some features that you need to calculate in real time, like the geolocation, but you may need to join it with the user's score. And the scoring is something that can happen on a daily batch. So when the model is actually running and you're sending the transaction ID or the event, you need to process the real-time feature engineering, but you still, at the same time, need to join the data with historical or operational data sets, and that's yet another challenge. Now, let's keep in mind that when the data scientists are developing their model, they don't have a production mindset in place. They think about how they can optimize the model. What's the best way to deliver the models in terms of their algorithm and the research that they're putting in place. but they don't really think about how it can run at scale, how it can run with different sources. Usually they're using Packet files or the database in the development environment, but in production, the reality is different, right? You may need to take the data from a streaming engine like Kafka or Kinesis, and oftentimes what needs to happen is basically to rewrite the code all the way from development to production. So we call it throw it over the wall, because the data scientist writing his own stuff using pandas and data frame in his development environment, but in production it's different frameworks, different requirements. You need to take care for all those aspects that I mentioned earlier around performance, scalability, security, management in general. And the data scientists, when they write the code, usually they don't think about those type of things. They don't have the production mindset in place, so you need to rewrite everything when you deploy it in production. Now, once the model is being deployed in production, then it's not the end of the game. Obviously, you need to monitor the model and identify if there is a drift. Now, drift could be based on data drift, feature drift. So you need that integration between the features that are actually running in production and the features that were trained in your training environment to be able to compare and identify if there is such drift. And upon the drift, what you want to do, you want to rerun the process again and retrain your model. And when you train the model, you may want to train the model on your fresh data from production, your recent data. So the consistency between the data in your training environment and serving environment is obviously very important. And last but not least, you do all that kind of stuff. You create this complex data pipeline. Now, you don't want to do it once and that's it. You want to be able to share it across your organization and basically reuse those features. So you may be able to reuse some of those data pipelines and the transformation that you've been created in other projects instead of reinventing the wheel again. So those were kind of the challenges. This is why we came up with our feature store. So as you can see, the feature store is basically at the heart of the machine learning pipeline. So at the left-hand side, you have the data. So a good feature store can support all kinds of data. It could be structured, unstructured, real-time data. Data could come from streaming engines like Kafka or Kinesis, or operational databases or offline data stores, whatever you. And then this raw data basically goes to the feature store. In the feature store, you're creating your transformation. So you're taking this raw data, you apply your transformation, like sliding windows aggregation and one-hot encoding, imputing all those transformation that you need for your model. You do that, you store those features in a way that you can catalog them with all the metadata. So you can easily search for features and you have good insight as a user for all the relevant metadata. And then essentially those feature sets are going to serve your training and your inference. Now, what are the big benefits of a feature store? First of all, a good feature store can support real-time event processing. This is what it's all about, and I'm going to show you that later on in the demo. So you need to be able to get events in real time from streaming engine and apply your logic on the fly on your features. And then the other thing that is important is that a good feature store basically provides a simple SDK for the data scientists to actually create those transformations, even if those transformations are complex. So you provide them an SDK in a way that they don't need to rewrite the code again once you take it to production. So you write your logic once, and this logic is applicable for your operational cluster as well. You don't need to rewrite it again. And the code is there. The data can go to both places, to an offline data store for training and sometimes even analytics, and also for the online feature store, which under the hood is a very fast key value. So you basically avoid, you'd like to avoid the situation where you throw it over the wall, this piece of code, to data engineers, and you re-engineer everything in order to deploy it in production. And that's the real deal here. That's why you can really reduce the time that it takes you from development to production, and reduce the friction from development to production. Another thing that is important is the integration with the model monitoring. So as I mentioned earlier, if you have the model monitoring and you know how to model or monitor the features that are actually running in production, and then you also have the features that were trained in your training environment, you can easily compare between those two and identify if there is a drift. And if there is such a drift, you want to re-trigger the entire pipeline again, and you want to train your model on top of the fresh data. So if you have these assets in your model monitoring that basically capture the features and the labels and create it as yet another feature set in your feature store, then you can actually close the loop, rerun the entire pipeline again, train the model on top of fresh data sets from production, and if the model is better, actually deploy that model in production. So let me show you a demo, and let me show you an example of how you can actually do that, how you can develop such a project. So I'm going to use this real-time fraud prevention project that we've done on top of our Iguazio platform. You're going to see how we can create a feature set and run those feature engineering in the development environment, and then how you can actually deploy it as an operational serverless function that can run in your operational cluster. And once you have the feature sets in place, then obviously the next step is to train your model on those features, come up with the best model, deploy that model, and use the model serving. In the model serving, basically use the same feature sets to enrich the transactions that is coming into your model in your production environment. And last but not least, obviously monitor the model, identify drift, and close the loop again if needed. So with that, let me go to the demo part. So here I'm logging into the platform. Just in general, in the platform, we typically work in the context of projects. So usually customers are creating different projects per their application requirements or business need, and then each and every project basically has its own business goals. So if I drill down to a specific project, I can see lots of information about this project, like the models, the features that are under this project, the jobs and the workflow, the real-time functions. Everything is basically in the context of project. Now, you can develop your project using your favorite IDE. It could be Python or VS Code or Jupyter, whatever you. I'm going to show you how it looks like here in Jupyter because it's just easier to show it here. So what we're going to see here is the following architecture. We have transactions that are coming in as real-time transaction from a serverless from a streaming engine. Then we have another set of data that simulate account activities like last login, password change, and so on and so forth. Then we have another feature set for the labels. All those feature sets goes into the online and offline feature store using Jupyter. In this case, you can do the interactive exploration. And once you are happy with your feature set, you can deploy it as an operational serverless function in your operational cluster. And this is the big thing here. How do you go from this development mode all the way down to deployment? And once you deploy this serverless function, now you can use it for your model serving in your inference there. So let's see how it looks like. So this is the data set. We have this CSV. This is the raw data. We have source, target, device, timestamp, and all kinds of other under features, categories, amount, age, zip, and so on and so forth. Now we want to take this data and create this transformation that I talked about earlier. We want to do things like date extractor, right? We want to take the date and convert it into hour or day of the week. We want to do things like mapping of the age values, one-hot encoding, sliding window aggregation. So I want to take the amount and I want to create sliding window aggregation, like the average or sum or the count in the last 2 hours, 12 hours, 24 hours. I want to do another aggregation per category for the last 14 days. And essentially, I want to push all of that into a feature set that later on will be used in production. Now, how do I do that? First of all, I create feature sets. This is how we do that, we are using an orchestration open source that is being driven by Iguazio. This is our open source called ML1. This is the MLOps, the leading MLOps orchestration tool. We're creating a feature set. We give it a name, transactions, the entity, which is the key itself. In this case, it's the source, timestamp, description, and that's it. We have a feature set. Now we want to create the graph that comprises of those different steps. So in the first step, I want to basically write my own custom code that takes this date and convert it into hours or day of the week. So I'm just putting this as a step in the graph. So this is the date extractor step. It's basically based on a Python code, simple Python code. So you can create your own code, you can create your own custom stuff, custom libraries, and add it into the graph. Then I want to use some built-in libraries to do the mapping and the one-hot encoding, and the other part that I want to do is sliding windows aggregation. In order to create those aggregation, just need to specify the column name, the operation, so it could be average, sum, count, max, the type of windows, 2 hours, 12 hours, 24 hours, and the sliding window itself. This is the other aggregation that I'm creating based on the category. And essentially, I'm going to see this transformation graph that comprises of those steps. The data is going to go into the Parquet file for training and into a very fast key value database for inference. And this is how that's going to look like. So once I push the data, I run the ingestion, I can see the actual data. Those are the aggregation, aggregated columns, the last 2 hours and 12 hours for the amount. This is the categories that I've applied, and the date extractor, the hours and the day of the week. If I go to the user interface here under my project, I can see those feature sets. So this is the transaction feature set. Drilling down from the transaction feature set, you have lots of metadata, so you can search based on that metadata. You can see all those features that are part of the feature set, transformation itself. You can actually view the code here pane. You can preview the data, and you can get statistics on each and every feature here. So by default, we are calculating all the typical stats for your features. So this is how you have the management and control from UI perspective. Obviously, you can search features by name, and you can do all kinds of things from the UI as well. So we have the feature set. Let's say that we are happy with it. We want to create another feature set. I'm not going to go through that because of time, but the other one is the user event. Essentially, it's the same thing. We're creating it. We're creating the labels data set, and now we want to deploy that in operation as an operational state. What does it mean? It means that we want to be able to create an endpoint that runs on, let's say, a Kubernetes cluster in a distributed way, listen to a streaming engine or get HTTP requests, and run this transformation on the fly on those events. Now, I don't need to rewrite the code again. I don't need to do anything special. All I need to do is basically run this deploy ingestion service. That's going to take my function, my serving function. I can specify a specific image or use the default image, whatever. And that's going to build a serverless function with an endpoint that basically gets those events and run all those transformations that we've seen in real time on those events that are coming in from my source. And my source could be HTTP, or it could be a streaming engine. In this case, we're using Iguazio v3 stream, but it could be Kinesis, it could be Kafka, it doesn't really matter. You can listen to the stream and process those events based on the stream and based on the logic that you defined in your graph. That's the thing, and the only thing that you need to do is basically to create or to deploy this ingestion service. Once you do that, obviously we have some testing in place. You can issue an HTTP request, you can get to see the results, and make sure that everything's up and running. And again, you can do that using HTTP request, or you can actually ingest data into the stream and see that the stream is actually working. So this is how you create those feature set and deploy it as an endpoint. Now, the next phase is to train your model. Now, before I train my model, I need to create what we call a feature vector. Feature vector is this logical entity that comprises of different features. Those features can be across different feature sets. So in our case, we have a bunch of features from the transaction feature set and all the features that are part of the events. This is the definition of the feature vector. Once I create a feature vector, the next thing is basically to fetch the data using get offline features. So we're getting a data frame back. Now with this data frame, I can run my training, I can train my model. I can save this data set as a Parquet file, as a snapshot, to keep it consistent. And then I can run my model. The way I run the model is basically by issuing this training job. And if you look at here, the input data set is this features vector that we've just created. So I'm using the feature vector as an input for my model, running the model, and eventually I'm going to have a model in place that is running, and I can use that in the serving layer. If I go to the feature vector here, I can see those feature vectors that we've just created. Drilling down, I can get to see all this relevant metadata, the requested features, the return features, the preview of the data, statistics, all that kind of stuff is basically part of the feature vector definition. So now I have the model, I have the feature set. Now I'm ready to deploy that model as a serving function. So this is the next step. So I'm writing this small class here with load and predict. We're using an ensemble in this case of 3 models. And in my serving function, again, I specify this feature vector as the feature vector for enriching the data. So whenever I'm going to get events to my model, the events are going to be enriched by the feature vector. So I'm sending a source in our case, and then this source is being enriched with all those features that we've seen in the feature vector. Another cool thing that we have here is imputing policies. So we can actually, impute. So instead of nulls, you're going to put a fixed value, or in our case, you can put some statistics that we're taking from the statistics that we're gathering on the feature vector, which is pretty cool. And then we have a serving function. The way to deploy the serving function is, again, pretty simple. You just run serving function deploy, and that's going to deploy a full serving function that can get those HTTP or streaming requests, enrich the data with the feature vector, and send the response back. If I'm going back to the UI, if I go to the models here, I can see those the model, the training model. Drilling down from the model, I get to see all those metadata information, so, hash and key and iteration, and the job that was actually running this model. I get to see preview, all the artifacts that are being generated with the model. And the nice thing in here is that it's also associated with the features that the model is expected to get. So this type of information is also available along with the statistics. And the last part here is that once the model is actually up and running, I want to take a look at and monitor the models. I can look at the model endpoints, provides us some useful information around the operational statistics like uptime and last prediction, latency, these type of things. But it also provides us indication on drift. So this is what I mentioned earlier, that we have this option to collect the statistics in production about the feature sets and the features and labels, compare that to the features that we're actually running in the training environment, and then based on that, we can identify drift and visual all those information. So once I drill down from a specific model, again, I get to see lots of metadata about it, but also the drift analysis indication, those metrics around TBD and Hellinger and KLD, and we can even drill down to specific features and see the expected versus the actual mean, standard deviation, minimum, maximum, all those features that we're collecting per feature. So you get the full cycle here. Another thing that you can do, you can go to the jobs and workflow, and here you get to see all the the relevant information about the jobs that we were running. So for instance, if we were training the models, again, with this feature vector, we have all the relevant information here about the jobs, the input data set that we've been using, the artifacts that we're generating, the results, logs. In the results, we can see basically the best iteration out of 3. And all those information statistics are basically being captured here, and you can visualize that in the user interface. So that's basically it. What we've seen here is kind of an end-to-end projects of fraud prevention. How you can actually create feature sets. You can play around with the feature set. You can deploy that as an operational serverless function, and then you can reuse that for both creating or training your model, and then essentially running a serving function that use this feature vector in your production, in your serving environment. And then the last mileage is obviously to be able to monitor that and identify operational stats and drift on your model. So maybe I'll leave some room for Q&A. How are we doing in terms of time?
We have about 3 minutes left, and if you check the chat, there's a couple questions in there for you.
Okay, so let me see. Okay, where can we get the code for the demo? So we have this ML1 repo git. I'm going to send it over in the chat later on. How do we add new features that were discovered later inside the store? So so adding new feature, again, what you can do, if you want to add a completely new feature set, this is how you do that, as I showed at the beginning. If you want to add yet another transformation, it means that you need to add another transformation into that graph. What that's going to do, it's going to basically run the ingestion graph again and calculate those features again. Because we don't know exactly what kind of manipulation you did, so obviously when you change the graph and the transformation, we need to rerun the transformation again. And you can basically create another version of the feature set and publish a new version, and then have your feature vector pointing to that new version. But there are all kinds of use cases for updating feature sets. Okay, I think I covered those questions that I saw in the chat. So that's pretty much it. I think to summarize, I think real-time feature engineering shouldn't be so complex if you're using a feature store. There are many benefits you can get out of a feature store that support real-time pipeline, and we will be more than happy to see you in our booth, answer your questions. So